Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Good day everyone, I'm Chia-Sing. I'm the starter of the presentation slide today. The title that we want to present is Golden Section Search Method for Maximum Power Point Tracking of Photovoltaic System. I will start with project description. In the project description, we can know that Golden Section Search Method can be used to find the maximum power point. By relating the Golden Section Search Method and the maximum power point tracking technique, we can obtain the maximum power point by changing the interval of voltage after each iteration until the optimal point of voltage is obtained. Next, for novelty and invention, Golden Section Search Maximum Power Point Tracking Technique can be used to optimize the photovoltaic system without using a buck boost converter. And it also can narrow down the range of value, hence the result can be get in more accuracy and it is fast response and guaranteed convergence.
Hi, my name is Pumpuling. I will be continue the presentation with the method. In this project, we will be using the Golden Section Search method to find the maximum power point tracking. In here, I will be explaining on the steps for this method. Firstly, we need to specify the function that we need to minimize. Then set the initial values x1 and x2 and also the golden ratio and the tolerance. Next, compute the S values by using the formula as stated in this flowchart. Later on, we will evaluate the values of power for this both S value S1 and S2. If the absolute B minus A is less than, then the iteration will be terminate. Else, compute the S values by using the formula for the next iteration. Then evaluate the power for this both S value. If the power at S2 is less than the power at S1, then A will be remain and S2 will become the new values for B. Whereas if the power at S2 is is more than the power at S1, then S1 will become the new values for A and B will remain. Continue to repeat the steps until the absolute B minus A is less than the tolerance for the next iteration. Thank you.
I'm Din Suyen. Now I'm going to present on the solution part. By using GSS method, we obtain these two graphs. First, the graph X, which represent the voltage lies on the y-axis, versus iteration K, we obtain the optimal point of voltage is 15.4179. Next, the graph F, which represent the power point, versus iteration K, we obtain maximum power point at 50.0011. For your reference, these are the two graphs in additional information, which are current versus voltage and the power point versus voltage. These two graphs are plotted using the function, where we can also assume on which voltage may also obtain the maximum power point. For example, through the graph of power point versus voltage, we can see that when the voltage is 15 something, we can get the maximum power point. So meaning that it is verified when we compare with the graph that using GSS method, we can also get the optimal point at 15.4179. That's all from us. Thank you.